Hello and namaste everyone. Welcome to my channel SigmaX. Today we are learning about solving the problem related to the efficiency of heat engine. A Carnot engine has 50% efficiency with a sink at 9 degrees Celsius. By how many degrees should the temperature of source be increased in order to raise the efficiency to 70%? Before solving this problem, let's learn about heat engine and its efficiency. Do you know what a heat engine is? It's a device which converts heat energy or thermal energy continuously into mechanical energy which can then be used to do mechanical work. Basically, heat engine takes heat from a source, converts as much of it as into mechanical energy or work and rejects the remaining part to the sink. Therefore, heat engine consists of three main parts: source, sink and the working substance. Source is a hot body at a constant high temperature from which the heat engine can draw heat, whereas sink is a cold body at a constant low temperature to which heat engine can reject any amount of heat, and the working substance is an idle gas which performs mechanical work when supplied with heat energy. In this figure, A represents the source at a high temperature Th, B represents the working substance and C represents the sink at low temperature Tc. Let the working substance B absorbs Qh amount of heat from the source A. Then, after doing W mechanical work, let the working substance rejects Qc, the remaining part of heat, to the sink C. Now, according to the law of conservation of energy, we can write W plus Qc equals to Qh, which gives us mechanical work W equals to Qh minus Qc. In heat engine, efficiency, which is denoted by eta, is defined as the ratio of mechanical work done to the heat energy absorbed by the working substance from the source. Since mechanical work done W equals to Qh minus Qc, efficiency can be written as eta equals to Qh minus Qc divided by Qh, or 1 minus Qc divided by Qh. If you want to express efficiency in percentage, then use this formula: eta equals to 1 minus Qc divided by Qh times 100%. In real life, no engine can convert all the heat energy absorbed from the source into work, so the efficiency of engine is always less than 1 or 100%. Note that for Carnot engine, Qc divided by Qh equals to Tc divided by Th. Therefore, the expression of efficiency for Carnot engine can be written as eta equals to 1 minus Tc divided by Th, or Th minus Tc divided by Th. From this equation, we can infer that to increase the efficiency of Carnot engine, either the temperature of source must be increased or the temperature of sink must be decreased. Now, let's solve our problem. If we read the question carefully, then we can find that there are two cases. In case number 1, a Carnot engine is given whose efficiency is 50% with the temperature of sink 9 degrees Celsius, or in Kelvin scale 282 Kelvin, and the temperature of source unknown. Whereas in case number 2, the same Carnot engine is given, but this time its efficiency is increased to 70% by raising the temperature of the source while keeping the temperature of sink constant at 9 degrees Celsius. In the question, we are asked to find by how much degrees the temperature of source should be increased to raise its efficiency from 50% to 70%. If theta be the raise in temperature of source, then we can say that Th dash, that is the temperature of source in case number 2, equals to Th plus theta, or theta equals to Th dash minus Th. Hence, if we find the values of Th and Th dash, then we can easily find the raise in temperature of source. Now, let's find the value of Th in case number 1. According to the formula of efficiency, we know that efficiency eta equals to 1 minus Tc divided by Th. Putting the values of eta and Tc, we get 0.5 equals to 1 minus 282 divided by Th. Solving the above equation for the value of Th, we get Th equals to 564 Kelvin. Hence, the temperature of source in case number 1 is 564 Kelvin. Also, let's find the value of Tc in case number 2. According to the formula of efficiency, we have eta dash is equals to 1 minus Tc dash divided by Th dash. Putting the values of eta dash and Tc dash, we get 0.7 equals to 1 minus 282 divided by Th dash. Solving the above equation for Th dash, we get Th dash equals to 940 Kelvin. Thus, the temperature of source in case number 2 is 940 Kelvin. Hence, the raise in temperature of source theta equals to 940 Kelvin minus 564 Kelvin, which is equal to 376 Kelvin. Since theta is the difference in temperature, we can write either 376 Kelvin or 376 Celsius degree. In this way, we can solve the problem related to the efficiency of heat engines. I hope from now on, all of you can solve these types of problem. Thank you so much for watching. If you like this video, then please don't forget to like, comment, share and subscribe to my channel. And also don't forget to press the bell icon so you can get notification when I upload a new video. I will see you guys in my next video. Till then, bye bye.